Welcome to one of our Space Science and Technology Portals lectures. The title of this lecture is Course Introduction. In this course, we shall know about the different satellite subsystems. Each subsystem is considered a building block in a satellite system. By the end of this course, you should be familiar with different satellite subsystems and their payloads. In this lecture, we will discuss the following inquiries. What is a satellite? What is a space system? How are satellites classified? What is satellite architecture? Now we start with the first inquiry. What is a satellite? A satellite is any object that revolves around another object. It can be classified into two types. The first type is a natural satellite, and the second one is an artificial satellite. First, natural satellites. An example of a natural satellite is the Moon. The Moon is considered to be a natural satellite with respect to the Earth, while Earth is considered to be a natural satellite with respect to the Sun, etc. There are lots of natural satellites in our solar systems. For example, Saturn has at least 53 natural satellites. An artificial satellite can be defined as a relay station in space used in transmission of different signal types such as voice, video, data communication, etc. Satellites can be used in many applications like broadcasting television signal, weather forecasting, navigation, and many other applications. The first satellite was launched by the Soviet Union and was called Sputnik 1. An artificial satellite must follow the global communication requirements of the government, military, and commercial organizations. Please bear in mind that throughout the rest of the course, we will refer to artificial satellites as satellites. Now we move to the second inquiry. What is a space system? So what is a space system? A space system is a system that consists of three main segments: a ground segment, a space segment, and finally a launch segment. A ground segment consists of space flight operations in which a facility is responsible for sending a flight plan to a satellite. A flight plan consists of the daily operation commands and payload operation commands, where the payload is a device mounted on a satellite, which performs the mission a satellite is sent to space for. Spaceflight operations is also responsible for receiving the telemetry data sent from a satellite. This data is analyzed to monitor the health status of a satellite. In the payload operations, mapping the user requirements into operation commands to be sent to the spaceflight operations takes place. The payload data processing extracts the data from the payload received data. A space segment is the satellite itself, while a launch segment is the launch vehicle which carries a satellite to its orbit. Finally, it is worthy to mention that a space country is one that possesses all the segments of a space system. Now we move to the third inquiry. How are satellites classified? Satellites can be classified in many ways. They can be classified according to their function, type of orbit, mass, cost, etc. Now we will illustrate the classification according to a satellite's mass. This table illustrates the different satellite types based on a satellite's mass. The masses shown refer to fully fueled satellites. Large satellites are over 1,000 kilograms, while medium satellites are between 500 and 1,000 kilograms. Mini satellites weigh between 100 and 500 kilograms. Microsatellites weigh between 10 and 100 kilograms. Nanosatellites weigh between 1 kilogram and 10 kilograms. Picosatellites range between 0.1 kilogram and 1 kilogram. Finally, the femtosatellites are below 0.1 kilogram. Now we move to the fourth and last inquiry. What is satellite architecture? Now let's talk about satellite architecture. Here we have a satellite block, and we shall explain its contents. It is composed mainly of two main partitions, the payload and the satellite bus. A satellite payload is defined to be a combination of hardware and software that work together to interact with external environment to perform the mission a satellite is sent to space for. Each spacecraft payload may be different from one another. Later, we shall discuss the different types of payloads of different missions. A satellite bus is the structural body and the primary satellite system, which consists of different subsystems. The subsystems included under a satellite bus are the attitude determination and control subsystem, the structure subsystem, the communication subsystem, the power subsystem, the thermal control subsystem, and finally, the onboard computer subsystem, which is also known by the Command and Data Handling Subsystem or CDHS. Now we start with the payload. As we mentioned before, the payload is dependent on a satellite's mission. In order to explain the different types of payloads, we have to first discuss the different types of satellite missions. A satellite mission could be remote sensing, communications, or navigation. In the case of remote sensing missions, a satellite is equipped with a camera used during imaging missions, while in intensity measurement missions, it is equipped with a radiometer. However, in the case of topographic missions, an altimeter is installed on a satellite. Weather satellites can be considered as remote sensing satellites. In the case of a communication mission, a satellite provides broadcast, for example DirecTV, or point-to-point communication services to users around the globe, as well as data and voice relay between a satellite in orbit and controllers on the ground. A satellite requires a transmitter as a payload in the case of message broadcast missions or transceiver in the case of personal communication or full duplex missions. Finally, in the case of navigation missions, a satellite has payload of clock and transmitter as in GPS satellites, where a GPS is a satellite used by the Navstar Global Positioning System. The first satellite in the system, Navstar 1, was launched on February 22, 1978. The GPS satellite constellation was operated by the 50th Space Wing of the United States Air Force. Now we move to the ADCS subsystem. So what is meant by ADCS? ADCS stands for Attitude Determination and Control Subsystem, where the word attitude in the field of space means the orientation of a spacecraft with respect to a certain reference. The term determination means to determine a spacecraft's attitude using real-time measurements or computations, while the term control means to orient a spacecraft to a desired orientation. In some cases, if a mission requires orbit control, the term ADCS is then replaced by AOCS, which stands for Attitude and Orbit Control Subsystem. How can the ADCS achieve its tasks? In order to perform the tasks of the ADCS, it should follow a control loop, which should basically look like this. The control loop has many components like the determination and control algorithms, the sensors, and the actuators. These components work together in order to control a satellite's attitude. Based on the given task, the reference attitude is determined. Now we move to the second subsystem, the structure subsystem. What is a structure subsystem? It is a metallic frame that integrates the different satellite subsystems. What are the functions of the structure? The functions of a structural subsystem are to enclose, protect, and support the other spacecraft subsystems and to provide a mechanical interface with the launch vehicle. The enclosure and protection functions are necessary, especially during spacecraft assembly and transportation from the manufacturing facility to the launch facility. Now we move to the communication subsystem. So what is a communication subsystem? It is a subsystem that enables a satellite to communicate with ground stations which control a satellite. Also, it is responsible for delivering the telecommand data that a mission requires from a ground station. What does the data sent to a satellite consist of? The data sent to a satellite consists of mission commands or control commands. What does the data sent from a satellite consist of? Information received from a satellite consists of satellite status telemetry and payload data. What is the basic construction of a communication subsystem? A communication subsystem consists of a receiver, a transmitter, and a wide-angle antenna. Systems with high data rates may also use a directional antenna. Now we move to the power subsystem. What is a power subsystem and how can it be useful for all of the other subsystems? A satellite power subsystem is used for providing continuous, regulated, controlled, and conditioned power to all of the other satellite subsystems within the specified operation period and during ground testing. A power subsystem is one of the most critical systems on any satellite because every other subsystem requires power. This makes the design of power subsystems the most important task facing satellite designers. What are the components of a power subsystem? As shown in the diagram, a power subsystem consists of four main blocks: the power generation, the energy storage, the power distribution, and finally, the power regulation and control. Solar arrays are the primary source of the generated power in a satellite. The excess energy compared to the load requirements is stored in rechargeable batteries. It represents the secondary power source that supplies the subsystems during eclipse and overloading periods. The functions of the power control and distribution unit are to regulate the generated solar array power, safely perform the battery's charging and discharging, and supply the subsystems with the required voltages through overcurrent protected switches. What are the main functions of a power subsystem? A satellite electrical power subsystem is dedicated to power generation and control energy storage and power distribution. The typical functions of an electrical power subsystem are to supply continuous power to the loads during the mission lifetime, to control and distribute electrical power to a satellite, to fulfill the load's average and peak power requirements, to provide regulated voltage bus to the loads, to provide command control capability and telemetry of the subsystem's health, and finally, to protect a spacecraft against any failures within EPS. How can an eclipse influence the power subsystem? The orbit of a satellite consists of a shadow period and an illumination period. The shadow period is about a third of the orbital period. During an illumination period, the energy sources are used, while in a shadow period, the stored energy is used. Chemical batteries are used as energy source. Now we move to the thermal control subsystem. So what is a thermal control subsystem? It is a subsystem responsible for controlling the temperature of a satellite's different devices. Now we move to the second question. What are the main functions of a thermal control subsystem? The purpose of a thermal control subsystem is maintaining the temperature of a satellite's structural components and its numerous devices within a specified temperature range under all required mission conditions. This subsystem is crucial to any satellite, as a satellite is usually exposed to large fluctuations in temperature. This fluctuation takes place due to the exposure of one of a satellite's side to the sun, while the opposite one is far away from the sunlight. Now we move to the final subsystem, the OBC subsystem. So, what is OBC? OBC stands for the onboard computer. It consists mainly of a microprocessor, memory, and interfacing chip to connect the computer to different subsystems. What are the main functions of the OBC? The OBC is considered to be the central brain in a satellite. It acts as the conductor of a chorus in a concert. It manages the flow of data between each subsystem. The OBC has two main functions. The first one is to receive telecommands from the communication subsystem, which can be in the form of real-time commands or tagged commands. These commands are sent from the ground, processed, and distributed to all of other subsystems. The second function of the OBC is to collect the data from the satellite subsystems to construct the telemetry data, which is forwarded to the ground control station. Now we have come to the end of our lecture. Thank you for your undivided attention.